Hello, everybody. We're going to keep talking about 3D shapes today. We're going to talk about a guy named Euler. His name looks like Euler, but he has a formula we're going to talk about. And we're going to talk about faces, bases, edges, and vertices. So we talked a lot about bases the last time that we were together. Bases name a shape. Remember, it doesn't mean bottom necessarily. Right? Prisms are going to have two bases. Pyramids are going to have one. And whatever shape that base is going to be the name of that prism or pyramid. Faces are what we call the sides of the shape. We'll say of the solid. That'll make more sense. So the flat sides of the solid are called faces. And a question you're probably going to ask me, are bases a face? Yes, they are. All the sides are faces. All right? That's the faces. Edges are where faces meet. They're the lines that you would draw when you draw a shape. So if I wanted to draw a hexagonal pyramid, like this, every single line I draw is actually an edge. They're all going to be where two faces are going to meet together. And then the last one is vertices. And that's where edges meet. Those are the points, right? Where the corners, if you want to think of it that way, where all of these edges meet together are all going to be vertices of a solid. And so those are like the four main things that you need to know about these shapes. And we're going to talk about some rules that can kind of help you to find those things. Okay? So let's start with prisms first. So prisms. We already said that for bases, they always are going to have two. That is the definition of a prism, right? So always two bases. For faces, we're going to call it n plus 2. Now, n, we're going to define over here as the number of sides on the base. So if the base is a hexagon, then n for us is going to be 6, because hexagons have 6 sides. If the base is a triangle, then n is going to be 3, because triangles have 3 sides. So however many sides that base has is going to be our n when we're talking about the prisms here. So bases, there's 2. Faces, there's n plus 2. Edges, there is n times 3 edges. So again, same idea with n. However many sides are on that base shape, multiply by 3. That'll tell me how many edges are in the prism. And then for vertices, it's going to be n times 2. So, what this is nice for, obviously if they give you a picture, it's not so bad. You can kind of count these things. But if they give you something that you don't know what it looks like, maybe they say a dodecagonal prism, and they want to know how many bases, faces, edges, vertices it has, well, we can just use this rule. So It's a prism, so it's going to have two bases. For faces, a dodecagon, we need to define what n is. Dodecagon has 12 sides, so 12 plus 2 is going to be 14 faces. For edges, we're going to do 12 times 3 for 36 edges. And for vertices, we're going to do 12 times 2 for 24 vertices. So those are the rules for prisms. And now you can apply that to any prism that exists out there in the whole world. All right. Now, pyramids have a set of rules as well, but they're going to be a little bit different for pyramids. So for pyramids, we know they are going to always have one base. For faces, instead of n plus 2, it's going to be n plus 1. Same idea as last time. The way I always remember that is for prisms, they have two bases, so you add 2 for faces. For pyramids, they have one base, so you add 1 for faces. For edges, it's going to be n times 2 this time, so a little bit different. And vertices is really interesting. It is also n plus 1. So one of the things that's really interesting about a pyramid is it always has an equal amount of faces and vertices. They are always the same. That's a kind of a cool little thing about pyramids. So, likewise, if we want to do the same thing, let's say we had a nonagonal pyramid. We can just use these rules to find out how many of everything it has. So it has one base because it's a pyramid. For faces, nonagons have 9 sides. 9 plus 1 is 10. Edges, 9 times 2 is 18. And vertices is going to be 9 plus 1, also 10. And so that's kind of the basics between faces, bases, edges, vertices. There's one more thing that we want to talk about today, and that is Eulers Formula. Now, Eulers Formula has to do with all this stuff. And this guy, Euler, is he's an OG in geometry. His name is actually, looks like this, but it's pronounced Euler. And his birthday is actually the day before mine, which is fun fact. Probably not the same year. Euler's rule. This guy Euler found out that if we're talking about three-dimensional shapes, that if we take the faces plus the vertices, they're going to equal how many edges there are minus 2. So the faces plus the vertices equals edges minus 2. All right. And that's kind of cool. I don't know if you can kind of scroll back on the YouTube feed and look at the last example we had and be like, oh yeah, that totally makes sense with this one. But what we can do now is we can say something like, hey, what if this thing says that there's a solid and it has 20 faces and 20 vertices. How many edges does it have? Well, we can just plug them in. 20 plus 20 equals E minus 2. 20 plus 20 is 40. E minus 2. Add 2. And this thing would have to have 42 edges. So that's one way we can do it. We can have a problem like that and just kind of find the other thing. The other way we can use Euler's formula is maybe that would give me some options and say, hey, could this make a solid shape if we had 10 faces and 16 vertices, and 22 edges. Would that make a solid? Would that make a three-dimensional shape? So if we plug in all of these things, 10 plus 16 is 26. 22 minus 2 is only 20. Nope, that would not make a three-dimensional shape, because Euler's rule has to be true if it is a three-dimensional shape. Cool. I think that's pretty much all you need to know for today. Main focus is those faces, bases, edges, vertices, being able to kind of find those things with what they give you as far a shape. All right. Sweet. Let me know if you have any help, need any help today at office hours. I'll be there, and hope to see you there. Later.